Should I start?
Yes, yes, yes.
So first of all, I would like to start with giving out the handouts for this presentation in case you want to look up, because the screen is pretty small, so you might want to focus on some details. I have 5 copies here, I guess that will be enough. Hello, my name is Marina, and today I stand before you to give you a presentation about my master thesis, to defend my master thesis under the topic of development of conceptual trust handling framework for Industry 4 wireless networks. So recently there has been paid much attention towards the new upcoming industrial revolution known as Industry 4. And this new manufacturing environment is expected to embed the following technological solutions, such as cloud computing, predictive analytics, industrial Internet of Things, and many others in a single wireless factory network. Such a heterogeneous environment imposes human to human, human to artifact, and artifact to artifact relationships. Now, for my master thesis, a particular case of Industry 4 has been studied, which is a smart production line installed in the premises of Aalborg University in Denmark. It is, you can see it here, it is a smart production line that's producing test mock-up phones. And with support of Erasmus Plus EPIC project, a collaboration with Aalborg University has been established. And with colleagues from Aalborg University, we have done a joint analysis of this field, of this particular Industry 4 case. And during the joint analysis, we have identified following industry requirements that are expected to be fulfilled in such an environment in the future. From the user stories, following requirements have been derived, and the requirements are data availability, centralization, and wireless connectivity. Besides the user required features, also conventional security means have to be established in such a system, and such security needs are confidentiality, integrity, availability, as well as mechanisms of access control, accountability, and auditing. As I have mentioned already, in this kind of operating environment, different trust and security relationships exist. There are trusts being built between different systems, human systems, and network and node elements. And that brings us to the research problem of this thesis, which is how to establish and maintain trust in Industry 4 wireless network. A goal of the master thesis, or a way how to overcome this problem, is to develop a conceptual trust handling framework for functioning in such an environment. To fulfill this goal, following research tasks have been defined. First of all, it is necessary to investigate the state, the user stories, and trust requirements of Industry 4, as well as examine how current production facilities that are set up in a test lab in Aalborg can transform in the future to cover the required user needs. And the first 2 points, the first 2 research tasks have been conducted jointly with the Aalborg University. From that point forward, I moved on to my own personal investigation. That is the study of various definitions and understanding of trust in related scientific areas. Since in Industry 4, nobody has actually ever touched this topic as of now. From the research from previous points, next task is to determine trust forming dimensions and to use these dimensions to develop a trust handling framework for Industry 4. As an end point of this thesis, I have also performed certain types of validation of the proposed framework. To start, I will present to you the results of the third task, which is the study of trust-related concepts in related scientific areas. After a systematic literature review, I have come up with to my opinion, three trust areas that are relevant for the Industry 4 case. And these areas are social systems, information systems, and distributed ad hoc systems. These areas are beneficial for Industry 4 environment because they consider different trust relationships, starting with human relationships in social systems and ending with completely artificial trust, computational trust relationships in distributed ad hoc systems. From these defined areas, I have found main sources and supporting sources in related literature. And I have derived the trust-forming metrics, trust-forming dimensions, and I have combined these metrics for each scientific area in structured models. To give you an example, let's consider a domain of social systems. Here, both trust actors, trust participants are human beings. You can see here is the truster, the person or a social group who is aiming to trust a certain entity in the system. And the trustee is also a human or a social group that is being evaluated by the truster. Truster is affected by external trust factors, internal trust factors, and its own personal belief factors. But also this trust assessment is affected by characteristics, personal characteristics of a trustee. And altogether, these metrics form the multidimensional trust, and I have defined 3 dimensions for this trust object, which are ability, affinity, and predictability. Now, moving on to the domain of information systems, the situation is quite similar here. We still have truster as a human being or a social group. But in this case, the trustee is not a human being anymore, it is an IT artifact. Let's consider a cloud service or a CRM system or similar. Now these are the listed features that are expressed by the IT artifact in 3 dimensions: performance, process, and purpose. And in a similar way, in the end, a multidimensional trust object is formed. Already in information systems trust study, it has been noticed that trust becomes less intuitive and instead moves on to a more quantitative, as a quantitative computing unit between 2 elements in the system. And this is also the case for distributed ad hoc systems. Let's consider a wireless sensor network, for example. In such an environment, you cannot ask a node about how it feels a particular element in the system. Therefore, the trust of the node can only be assessed by using mathematical trust functions. For example, data packets delivered. It's just a percentage of how many packets are lost in the process, and this is how you determine trust. And this is only one example. Altogether, between 2 nodes in such a system, you can define 3 trust dimensions: cooperation, data integrity, and availability. However, in related literature, I have not found any signs of human trust being taken into consideration, and I found that strange because in the end, the human user is the one who utilizes this wireless sensor network. Therefore, I have added a similar block as from the previous information system model, which considers also the human relationship, trust relationship with the node network as a whole integral entity. And in the end, a multidimensional trust object consisting of 7 dimensions, the dimensions have been formed. And moving on to conceptual trust handling framework for Industry 4. From the presented models, especially from the model for distributed ad hoc systems, I have derived following requirements and following trust dimensions for this particular task. Dimensions are data integrity, cooperation, credibility, initial and continuous credibility, performance and process, access control, and recommendation. Now, before I go into detail about the framework, another aspect I have noticed in related literature is that different approaches to trust exist. Namely, you can consider initial trust when the node firstly joins the network, or you can consider continuous trust relationship that gets updated over time. And the other perspective that I have already mentioned in the model for distributed ad hoc networks is node versus network trust, where node network trust is purely technical, Network trust can also involve some kind of a human perception taken into consideration. As you can see in the trust handling framework in the slide here and also in the handout before you, here are the concepts I have mentioned. For instance, let's consider node part of the diagram, node part of the framework. Here you see the node initial trust module and a node continuous trust module over here. And on the right side of the diagram, there is a network-based perception of trust. Now to give you an example of particular parts of this framework, let's start with the node initial trust module. This trust assessment step has to be passed for all the elements that join the Industry 4 network. And it covers two dimensions, dimension of access control and initial credibility. In access control block of the module, even though this is a trust dimension by itself, it is also a trust function, and it considers following steps to be fulfilled for the element to join the network. If these steps are not fulfilled, if the element is not authorized and authenticated, an alarm is raised in the system. On the other side, you can see the initial credibility trust dimension, and at this step, particular features and characteristics of element are considered. And my suggested trust functions here are vendor data validation, firmware validation, and software validation. But these functions can vary depending on the particular case of Industry 4 that you are using. These trust dimensions, lower level trust functions, are combined using a higher level trust function. And in the end, a total trust value is for this node in this dimension is delivered as an output. If this element is below a certain threshold, alarm is again raised in the system, and you might consider not allowing this element into the network. As for continuous trust module, in general, a similar process happens here, but this trust assessment is not one time, it is being repeated regularly. It is being repeated regularly. Yeah, I think I will not go into too much detail about this. About the network trust engine, there are two trust engines in the system, node trust engine and network trust engine. The node trust engine is responsible for collecting all trust dimension values together and deriving a certain trust evaluation per one node. And then this value is being fed into the network trust engine, to which from the other side also a network trust dimension value is being delivered. And this network dimension trust value also considers human perception of the system. And in the end, you get the system trust to evaluate the overall performance and trust characteristics of that network. I have also performed the validation of this framework. At a certain extent, validation has been given from the paper submitted to the DBIS conference. And the contents of this paper were only the trust models that I have presented in the first part of this presentation. And by myself, I have also performed validation of the framework from two perspectives, one being a problem-specific validation and the second one being a framework-specific validation. As for problem-specific validation, for this case, I have used requirements that I have presented in the beginning. Meaning this is the evaluation of how this framework could support the industry needs that are, for this particular case of Industry 4, placed in Aalborg University. And there are three origins of the requirements: required features from user stories, network challenges, and conventional security requirements. And the way I approach validation is I determined the relevance of each metric from this origin. And for instance, if we consider the requirement of centralization, I have concluded that it is highly supported in the framework, and it is fulfilled by using centralized trust processing and centralized trust storing. And these These elements are fulfilled by using components of node trust engine, network trust engine, and trust storage. Now, if we talk about requirements that are not relevant for the framework, we can consider the requirement of low latency. And this is not relevant for the framework because the conceptual framework cannot support technical needs. It cannot support technical measurements. And for this particular requirement, you have to build the system and approach this question from a technical perspective. You can see the full validation table here on the slide. As a conclusion, I concluded that all requirements for industry that are relevant are supported in the framework, and one requirement of mobility is not supported by the framework, but rather affects the trust evaluation in the system, since if you remove nodes around in the system, it will also affect the trust elements, the trust evaluation that you already have for these elements. Another approach I took with validation of the framework is framework specific. This kind of validation does not consider the context of the framework. It does not consider the particular industry for case. I have found similar trust. Should I stop? Okay. So I have found similar frameworks and trust models in related literature. And I have concluded that similar works often separate trust in three phases, which is trust assessment, trust gathering phase, trust assessment phase, and trust storage phase. Now, if we consider a particular case of trust data gathering, what it means is that at this point we select the functions for calculating the trust, and we select the trust calculation methodology. The whole calculation happens only as a next step in trust assessment phase. Now, for this particular trust gathering phase, I have determined which metrics are relevant from this particular industry for case, and which of these metrics are in general important to trust evaluation. So if we consider a metric of accuracy from related works, it is highly relevant in this framework because it is actually implied by the data integrity trust dimension itself. And of course it is also very highly important because if you don't get accurate trust results, what is the point of having a trust evaluation framework? Here you can see the full tables of framework-specific validation. And the conclusion is that important factors of efficiency, accuracy, technique, confidentiality, and security are fully or partly supported in the framework. And about 40% of the metrics actually have low relevance because a conceptual framework is not able to support such metrics. In general, I can conclude that this work has made a huge contribution to studying security needs and user needs of Industry 4. As I mentioned before, it is an emerging field and not a lot of previous literature on this topic exists. Besides this, trust interpretations in different related areas have been combined in trust models, and a certain approach to unification of trust has also been conducted. From these previous points, Industry 4 trust dimensions have been found and merged into a conceptual trust handling framework. As for validation, it has been validated against industry requirements and against related metrics. Another thing to point out is that since it was a collaboration with Aalborg University, on their part, researchers from Aalborg University have already taken the access control dimension to fulfill this dimension by means of introducing authentication protocol, which is based on a blockchain identity management system. And as for further research, evaluation of proposed framework should be continued further. A deeper industry expert survey is needed to understand if this framework actually meets the user needs, as well as practical application of this framework is required by taking by taking an incremental approach and building parts of the framework step by step. And from academic research perspective, a deeper focus on trust function selection is needed, as well as trust function calculation methods should be considered for this task.